Here is the video for the step 4 of 8 for our chapter 2 ladder review. Number 1 says for this step is solving this inequality, and what we're going to want to do here is factor this cubic polynomial here. The very first thing I'm going to do is, because I have this negative out in front of the x cubed, I'm going to go ahead and factor that out. That's just a lot easier in my mind to factor without that, and then that'll change all of these signs. And to factor this cubic polynomial, we're going to factor by grouping. So I'm going to factor these two pieces and factor these two pieces. When I'm looking at these first two terms, they both share at least an x squared, so I can take that out. So on the inside here, I'm going to take out an x squared. On the inside, that's going to leave me with x and then minus 3. On these two, I can take out a negative 4 from both of these terms, and that leaves me with x minus 3. And altogether, when I'm looking at this, these two terms are going to be one of our factors. So on the outside, I'm going to have this negative, and we'll have x squared with a minus 4. And then last but not least, these x minus 3's match, which means I get one of those as one of my factors. I'm going to say that those are greater than 0. And now what I'm going to need to do is I'm going to need to set both of these individual factors equal to 0, greater than 0. So I'm going to do that here. So I'm going to say x squared minus 4 is greater than 0. And I can add 4 to both sides. That gives me that x squared is greater than 4. And I can square root both sides, which gives me a plus or minus here. And that's going to tell me that x is greater than plus or minus 2. Then for x minus 3, I do the same thing. I'm going to say x minus 3 is greater than 0. And if I add 3 to both sides of this inequality, I get that x is greater than 3. So now I have the 3 areas that I'm going to be checking. So I'm going to go ahead and create that number line with 3 numbers on it: negative 2, 2, and 3. And what I want to do is I want to go ahead to figure out what the solutions are, the sort of range of solutions. I'm going to want to check all 4 of these areas, numbers that would be in those areas, plug them back into my original polynomial, and see if those outputs land where it makes the inequality true. So I'm going to look over here and say, well, I can check when x is equal to negative 3 because that's less than negative 2. Between negative 2 and 2 is 0. Between 2 and 3 would be when x is equal to 2.5. And when x is greater than 3, we'd say, well, how about we check when x is equal to 4? And we'll see if these pass or fail. So I'm going to grab my calculator, and going back to the top here, I'm going to plug in negative 3 in for my x values and see, is that answer greater than 0? Does it pass or fail? So I'm going to go ahead and do that now. So I have negative input, negative 3, and that's cubed, plus 3 times negative 3 squared, plus 4 times negative 3, plus 12. And that gives me positive 54. So is positive 54 greater than 0? Yes, it is. So this area passes our little test. I'm going to do the same thing. What's nice about these TI-84 calculators is I can go back and just copy and paste. So I'm going to do that here, and I'm going to change all of these now to zeros, because that was the next number that I'm going to test. So just go back in here, test, plug in these zeros. If I plug in 0 into this function here, is that, or this polynomial, is that greater than 0? And it's showing positive 12. It should not be doing that. This was minus 12. Sorry about that. That was minus 12 on there. I'm not really sure how that changed. So if I plug in zeros in, all of these become 0. 0 minus 12 is negative 12, and negative 12 is not greater than 0. So this fails the test. Between negative 2 and 2 fails. So then I'm going to check positive 2.5. So I'll go ahead and just rewrite this one so I don't mix it up like last time. So 2.5 cubed plus 3 times 2.5 squared plus 4 times 2.5 minus 12. Got to make sure we have the minus 12 there. And we'll go ahead and check that. 1.125, is that greater than 0? Yes, it is, so that passes. That passes. And then last but not least, we will check when x equals 4. So I will go back in. I'm going to copy and paste this one, try and save a little bit of time. So we'll change these inputs to 4. And see what that gives us. And that gives us negative 12. And negative 12 is not greater than 0, so this part fails as well. So now what I'm going to do is say, okay, well, on this number line, I see where I'm passing, and so those are the intervals that I'm going to say solve this inequality. So it looks like the interval from negative infinity to negative 2 not inclusive, along with negative 2, or excuse me, this is positive 2, so positive 2 to positive 3. So that is going to be the intervals where this inequality is solved, or is greater than 0. Alright, so that was number 1. Number 2, a little bit different here. Here we're going to have a rational function. And so the way that you probably want to go about doing this, I tried this a couple ways, but the way that I think really works the best here is let's go ahead and factor this top polynomial. So what two numbers multiply to 56 that if I add them together give me 15? That is going to be 7 and 8. So I know that these factor to x plus 7 and x plus 8. We're saying that is less than or equal to 0. Okay. And what we're going to go ahead and look at here is, again, sort of the same stuff. We're going to say, okay, well, negative 7 or negative 8 would make this whole thing go to 0. So when I'm doing my number line here, though, there's one other area that I need to check. So I have negative 8 and negative 7. That would make this go to 0. I cannot have negative 6. Negative 6, there is a vertical asymptote at negative 6, so I need to include that. I need to include that in my numbers here. So anytime you have an asymptote, you got to have that on your number line as well. So I'm going to do the same thing. I'm going to look at these numbers, and so I'll check numbers like, we'll say, how about when x equals negative 10? That seems like a nice number. When x equals negative 7.5. When x equals negative 6.5. And we'll say, how about when x equals negative 5? Okay, so I'm going to do the same thing. I'm going to see, do these numbers inside of these intervals pass or fail? So again, I'm going to get my calculator out again. Be really careful here. be really careful, because when we have fractions, our calculator sometimes thinks we're saying things that we don't mean. And so what we're going to do is we're going to go ahead and take the original function, and we're going to go ahead and plug in -10 into the top. And really, let's do this. Let's put 2 parentheses here, and I'll show you why we're going to do that. So I have -10 squared plus 15 times -10 plus 56. And I close that, and I'm going to close it again. And I'm going to say that I want to divide that whole thing by x plus 6. And I'll put x plus 6 in parentheses. We'll say -10, because that's what we're inputting, and then plus 6. And we'll close that as well. Looks like I plugged in something wrong there, so let's go ahead and try that again. What I'll do instead, actually, let's just go back and say I'm going to plug in -10 squared. I think I tried putting in too much and made it a little more complicated. So we'll say -10 plus 56. So that whole thing on the top is going to be positive 6. And if I divide that answer by what? By -10 plus 6, that's going to give me -1.5. So I'm going to say, is -1.5 less than or equal to 0? Yes. So this is going to pass. And I'm going to do the same thing. So I'm going to say, let's check -7.5. So we'll say -7.5 is 15 times -7.5 plus 56. So I'm just entering the top part, and then I'm going to divide that by the bottom, -7.5 plus 6. And that gives me a positive number. 0.166 is greater than 0, so that's not going to work. This fails. Next interval I'm going to try in between -7 and -6. We'll try -6.5. So I'll just do the same top part, but I'll just change -7.5 to -6.5. And if I divide that by -6.5 plus 6, that gives me -1.5. -1.5 is less than or equal to 0, so I'm going to say that this passes as well. And last but not least, I will check -5. I'm just going to copy and paste this again. We'll say we want -5. So -5 squared plus 15 times -5 plus 56. That gives me a positive 6. And I'm going to take that answer and divide it by -5 plus 6. I didn't like that. Yeah, so when I plug that in, that ends up being 1. So if I divide by 1, that's still going to give me 6. And 1 is not less than or equal to 0. So over here, that fails the test. So when I'm looking at my intervals here, again, this says less than or equal to 0. So that means that I actually get to include these values that give me 0. So I'm going to say that my intervals here are going to be from -infinity to -8 inclusive, because I can actually have -8 because of this less than or equal to 0. And then -7 inclusive, so having the bracket there, up to -6. I can't have -6 though, because again, -6 would make this whole thing go to 0. And that is it for number 2.